everyone. In this session we are going to discuss the modified duobinary encoder with precoder. So for what purpose we are using precoder? Precoder is used to avoid the error in the received signal sequence. So this is what the transmitter section of the encoder, the encoding section of modified duobinary encoder. The input binary sequence BK, it might be 0 1 value, we can give it to the precoder. Precoder is consisting of an XOR gate, along with the another input of it is the decay minus 2. Decay is delayed by 2 dB. So this decay we can then give it to the level shifter. Level shifter will convert this decay into AK, means 0. If decay is 0, it will be converted into -1. If decay is 1, it will be converted into +1. AK is then given to the subtractor, whose another input is from the delayed version of this AK by 2 bit, that is AK minus 2. So what will be the value of CK? CK is equal to AK minus 2. This is AK minus AK minus 2. Now this is what the output of the encoder, we can give it to the decoder now. So this is what the received sequence CK, we can give it to the rectifier, which will gives us the modulus of this CK value, and then we can give it to the decision device, which can be set at the threshold level of 1 and make the decision BK is equal to 0 if mod of CK is greater than 1, and BK is equal to 1 if mod of CK is less than 1. So this decision is very important. The value of BK is 0 if mod of CK is greater than 1, and it is 1 if mod of CK less than 1. Now let us look at the problems now. Example. So this is what the problem statement: the binary data stream 0010110 is applied to the input of the modified duobinary system. Construct duobinary coder output and corresponding receiver output. Assume that there is precoder at the input. So for this given sequence, they ask you to calculate the modified duobinary encoder output and decoded output also when precoder is available. So here I have prepared a table for that. So this is what the table I have already prepared. Now the binary sequence which is given to us 0010110, I have already written. We can always start from 0th bit, so 00110. Now the next we can write the value of decay minus 2 and decay. So don't write decay minus 2 value, first of all write the value of decay. So initially we can consider the value of decay as 1. You may consider this value as 0 or 1. I have considered this value as 1. That's why I have make here star. Since we are dealing it by the 2 bit, that's why I have considered 2 ones here. So this one. Now I can write here this, since this is the delayed version of this by 2 bit. So this one is going here, this one is going here, and this one is going here. Now decay is equal to BK XOR with decay minus 2. So addition of this BK XOR with decay minus 2. So it is not simple addition, it's a XOR addition. 0 plus 1 is 1, 0 plus 1 is 1. Now this one is going here and this one is going here. So 1 XOR with 1 is 0 and 0 XOR with 1 is 1. This one is going here and this 0 is going here. So 0 is going here and this one is going here. So 1 XOR with 0 is 1, 1 XOR with 1 is 0, and this one is now going here. So 0 XOR with 1 is 1. Now 2 level sequence AK. AK means what? When decay is passing through the level shifter, we will get AK. So just need to write the polarity. 1 means +1, 1 means +1, and 0 means -1. So 0 means -1, 1 means +1, which we have written here. Now this AK we can delete it by 2 bit. So this +1 will be going here, this +1 here, this +1 here, +1. So it's just a delayed version we have written here. Now duobinary encoder output. So CK is equal to AK plus AK minus 2. So need to just add this to AK and AK minus 2. So it's now addition, not XOR addition, simple addition. So 1 plus 1 is 2, 1 plus 1 is 2, -1 plus 1 is 0, 1 plus 1 is 2, 1 minus 1 is 0, -1 plus 1 is 0, 1 plus 1 is 2. Now mod of 2. So plus 2 is 2, 2 is 2, 0. So we can take the mod. If there is negative sign, that will be converted into the plus sign, but there is no negative sign. So now the final output of decoder BK here. So what is the decision? If BK is equal to 1 if mod of CK is less than 1, and BK is equal to 0 if mod of CK greater than 1. Now since mod of CK here it is greater than 1, it means it is 0. It is 0. Mod of CK greater than 1, since it is 2 greater than 1, so 0. Here it is also 0. Now less than 1, so this will be 1. greater than 1, so this will be 0. This is 1. This 0 value means it is less than 1, so less than 1 means 1, and this value is greater than 1, so it will be 0. This is how we are getting our original sequence, that is the decoded one, 0 0 1 0 1 1 0. You can see the same sequence that we have actually given as an input. So this is how we have decoded the original sequence.